first part of section 10.2 is on combinations. Now, in the last section, we talked about permutations, and that's where the order matters. So ABC is not the same as CBA. In combinations, the order doesn't matter. So ABC and CBA are the same thing. All right, so we have a formula for finding combinations, and if you'll remember the last part of the last section, when there's a repetition, you divide by that repetition. So that's what we're doing here. If we've got combinations, n number of combinations, take an r at a time, what you're going to do is take that number factorial divided by the difference between the number in total and the number you're taking, factorial that, and then multiply that by the number that you're taking. Let's do a couple and I'll show you what I mean. So if you've got, you know what, there is a child that loves to read and they've got 10 books on their bookshelf, 5 fiction and 5 nonfiction, and their parents read to them a set of 4 books every night. That's a long bedtime ritual, but that's okay. So they're going to read 4 books. How many different sets of 4 books are there? How many different combinations of 4 books are there? Now, in this case, it doesn't matter if you read Little Red Riding Hood before the 3 Little Pigs or after. You're still reading that book, all right? So if we want to know how many sets of 4 different books we've got out of these 10 books, 5 fiction and 5 nonfiction. And in this case, do you see that for this problem, we don't even care if they're fiction or nonfiction. So that's extraneous information for right now. So for this problem, I've got 10 books and I want to take 4 of them in each set. So I'm going to use my formula here, the combination of 10 books taken 4 at a time. And I did not give myself much space here, did I? Whew. All right, so what we're going to do is we're going to take n factorial, n is your 10, so 10 factorial over 10 minus 4 factorial times 4 factorial, because that's my r. All right, and so now it's just a matter of working them out. So we've got 10 factorial over 10 minus 4 is 6 factorial times 4 factorial. And remember all those factorials, you can't just take 6 times 4 and get 24 factorial. It's not the same thing. All right, so what I would do in this case is take 10 times 9 times 8 times 7 times 6 factorial over 6 factorial, which marks out, times 4 times 3 times 2. And then you can, 4 and 2 are 8, and 3 takes the 9 down to 3. So now 10 times 3 is 30, and 30 times 7 is 210. There are 210 different sets of 4 books that this parent can read. Whew, that's a lot of different nights. That's almost the whole year. Woohoo! We got a different combination of books each time. Okay, so now what about, I've got those 210 different combinations. In how many of those 210 groups are they either all fiction or all nonfiction? Now we could set up a cute little tree diagram and find out where all of those books are and where all 4 of them are fiction or all 4 are nonfiction, but I've got a better way. All right. Sometimes we've got to decide, are you going to, in this case, we're going to multiply some combinations because we've got, how many different choices do we have? In this case, we've got fiction or nonfiction. So we've got the combination of 2 choices taken 1 at a time. That's 2 choices, fiction and nonfiction. We're going to take that combination times the combination of 5 books taken 4 at a time. Okay, so do you see where these come from? So this one is easy. I want a group of either all fiction or all nonfiction. So that's where the 5. We've got 5 fiction books to pick from, and I want to pick 4 fiction, 4 of them. All right, or 5 nonfiction and 4 of them. The reason we have this is because we're going to do this for fiction and we're going to do this for nonfiction. So we've got 2 combinations here and we want one or the other of those. So that's where this combination came from. So now if we multiply those combinations together, that's going to give us how many groups of either all fiction or all nonfiction. So when we work this out, the combination of 2 taken one at a time, that's 2 factorial, and I left this up on purpose. Make sure you put that in your notes. You will want that. All right, 2 factorial over 2 minus 1 is 1 factorial times r factorial is just 1 factorial, and 1 factorial is the same as just 1. So 2 factorial over 1 factorial times 1, this is just equal to 2 because 2 factorial is just 2 times 1. So all of that is equal to 2 times 5 factorial over 5 minus 4 is 1 factorial, and over 4 times 4 factorial. So now we've got all of this is just equal to 2 times 5 times 4 factorial over 1 is just 1, 4 factorial. Those cancel out, and 5 times 2 is just 10. See where the numbers came from? So this part is simply just make it, the computation, just working it out. So where do you come up with these is the important part here. And then can you put this information into the formula? That's what you're needing to be able to do. All right. Once you've got your head around, okay, this is combination, this is the formula, this is how we use it, now we're going to throw other stuff at you. If you've got 2 events happening, and this is kind of what was going on. We had either fiction or nonfiction. If you've got two events, you've got to know, are you going to multiply those we're going to get to probability later, those combinations, or are you going to add them? If you want to know both and, you're going to multiply those combinations. If you want to know or, then you're going to add. Let me show you what I mean. We've got a student senate and in a school, and on the student senate we've got 6 seniors, 5 juniors, 4 sophomore, and 3 freshmen. They're sitting on the student senate. Now we want to make different committees of these different students, and I want to know how many committees of exactly 2 seniors and 2 juniors can I make. So what we need to do is this. We've got seniors and we've got juniors. That's two different combinations we're dealing with, but we want to know, we want to do both. We want to do and, so we're going to multiply our combinations here. We're going to find out how many committees that can we have of 2 seniors, and then how many committees can we have of 2 juniors, and then we're going to multiply those combinations together. So we want to know the combinations of 6 seniors taken 2 at a time, because we want 2 of them on each of those committees, and we're going to take the combination of 5, because that's how many juniors we have, taken 2 at a time, because that's how many we're going to put on the committees. Okay, so then once we get really and truly, this is the hardest part, figuring out where did these numbers come from? So we've got 6 seniors and we need 2 of them. We've got 5 juniors and we need 2 of them. That's where these numbers came from. So now we're going to simply use our formula. So we've got 6 factorial over 6 minus 2 is 4 factorial times 2 factorial. And then we're going to multiply that by 5 factorial over 5 minus 2 is 3 factorial times 2 factorial. And now it's a matter of just simplifying it down. So this is 6 times 5 times 4 factorial over 4 factorial, which is going to cancel, times 2 times 1 is just 2. So you can reduce that down to 3 times 5 is 15. And then we're going to multiply that by 5 times 4 times 3 factorial, and 3 factorial, which will cancel out, times 2. And then 2 times 1 is easy. All right, so then reduce that down to 2. 5 times 2 is 10. So now 15 times 10 is 150. So there are 150 different combinations of committees that we can make up that have exactly 2 seniors and 2 juniors. And then the others don't necessarily matter. We can have other students as well. But if I want exactly 2 seniors and 2 juniors, there are 150 different combinations that I can make of that. All right. So now, that was and. We're going to multiply them. Now, what if I want to know how many committees can I make up of these students that have at most 4 students? And now you're going to say there's no and or in here. What on earth? What this means is this. If I want to know the number of committees of at most, that means I want to know how many have 0, how many have 1, how many have 2, how many have 3, or how many have 4. So all of those options together. So that's why we want to add all of those choices together, because I want to know how many combinations of, let's see, 11, 12, 30, 40, 50, 60, 70, 18. How many combinations of 18 students do we have 0 on a committee? Plus the combinations of 18 students where we have 1 on the committee, plus the combination of 18 students where we have 2 on the committee, plus the combination, you're getting long, and 18 that have 3 on the committee, plus the combination of 18 students that have 4 on the committee, and I want at most 4, so no more than 4. So these are the options that I want, and I want to add them because I can have any of those. I don't want all of them. So I'm not going to add. I'm not going to multiply those different combinations. I'm going to add together. Okay, so I can have. Well, let's work it up and see. So we've got combination. Let's see. So 18 factorial over 18 minus 0 is 18 factorial times 0 factorial is just equal to 1, plus 18 factorial over 18 minus 1 is 17 factorial times 1 is just 1. We're going to leave that. Plus the combination 18 factorial over 16 factorial times 2 factorial plus 18 factorial over 18 minus 3 is 15 factorial times 3 factorial. It's getting long, huh? 18 factorial over 14 factorial times 4 factorial. All right, and this is where it becomes easier to reduce things out. 18 divided by 18 is just 1. And then this is going to be 18 factorial over, or 18 times 17 factorial over 17 factorial is just 18. So 1 plus 18. Plus this is 18 times 17 times 16 factorial over 16 factorial times 2. So this is 9 times 17 is 153. And then this one here is 18 times 17 times 16 times 15 factorial over 15 factorial times 3 times 2. And 3 times 2, let's take it out of 18. 18 divided by 6 is 3. And 3 times 17 times 16 is 816. And then the last one is 18 times 17 times 16 times 15 times 14 factorial over 14 factorial times 4 times 3 times 2. So the 14 factorials will reduce. 4 will go into, let's take, 4 will go into 16 4 times, and 6 will go back into here 3 times. 6 times 3 is 18. So 3 times 4 is 12. 12 times 17 times 15 should be 3,060. And if you add those up, we should get 4,048. And I didn't actually, that made it look like I did that in my head. That's pretty cool, huh? You know what? I wonder if you can even see that. Did I go down too far? After all of that? Oh, good, you can. I'm so glad. All right, so what this represents, what that number represents is there are 4,048 different ways that we can make combinations of students to make committees where they have at most 4 students, where they either have 0 students or 1 or 2 or 3. So 4,048 is our is our total there. Okay, so now last one here. All right. So now what we can do, now that was cumbersome and we were adding them up, but if we were to have to start with 18 and subtract, that's actually more cumbersome. Sometimes it's easier to subtract off what's not true than to add up what is true. Let me show you what I mean on this one. So if I'm going to flip a coin, I'm going to toss a coin 10 times. I want to know the number of ways that at least 4 of those coin tosses will show up heads. So in this case, if I want at least 4, so that means we want 4, 5, 6, 7, 8, 9, or 10. That would be, so we already did what, 1, 2, 3, 4, 5. They already did 5 of those, and that was crazy cumbersome. But if we were to go from 4 to 10, that's 7 different combinations that we're going to have to add up. That would become more cumbersome. So if you've got more that you're adding, then what we can do is we can actually subtract, and we can take, okay, so let's take the total number of possible outcomes. So the possible outcomes, the possible combinations, and let's subtract the ways that are not, the combinations that are not included here. So in this case, we're going to take the possible combinations of 10 head tosses, coin tosses. So what that is there's 2 choices, right? So there's either heads or tails. There's 2 choices, and we're going to do 10 times. So we're going to do 2 10 times, right? 2 choices 10 different times. So 2 to the 10th power is what we've got. So that's a total of what, 1,024? There's that many different possible outcomes. All right, so now what we're going to do is we're going to take those total possible outcomes, the total combinations, and we're going to subtract off at the times that there were 3 or less that showed heads. Is that making sense? Am I totally crazy? All right, so what we're going to do is I want the combination of 10 taken, what did I say? Taken 0 at a time. Okay, taken 0 at a time, because if it's at least 4, we want to start at 4, but we're going to start, okay, so we didn't include the 0. We didn't include the combination of 10 with 1, or the combination of 10 with 2, or the combination of 10 taken 3 at a time. When we got to 4, we want to include 4. So because it's at least 4. So we don't want to include any of those. So now we can just take the total number of combinations, and we're going to subtract all of this. So now we're going to do exactly the same thing we just did. So do you remember that the formula that I covered up here? So we're going to take 10 factorial. Actually, anything taken 0 at a time is just going to equal 1. So you don't even have to work that. Plus 10 factorial, 10 minus 1 is 9 factorial. Times 1, we don't have to put times 1. And then 10, factorial over 10 minus 2 is 8 factorial times 2 factorial, plus 10 factorial over 10 minus 3 is 7 factorial times 3 factorial. All right? And so we're going to take 1 plus 10 times 9 factorial over 9 factorial is just 10, so 1 plus 10. And then plus 10 times 9 times 8 factorial over 8 factorial times 2 factorial. 8's cancel out. The 2, we'll make that down to 5. 5 times 9 is 45. 10 times 9 times 8 times 7 factorial. The 7 factorials cancel. 3 times 2. Let's take 2 out of the 10, or 2 out of the 8 and make it 4. 3 out of the 9 and make it 3. 3 times 4 is 12, times 10 is 120. 120. All right, so add that all together and we get 176. 41, 40, 50, 67, 176. So we want 1,024 minus 176, which is 848. Woo. Okay, so all of that, there's a lot of computation in here. If you want to put those into your calculator, and 10 factorial divided by 9 factorial, and it will spit out 10. 10 factorial divided by 8 factorial times 2 factorial, and it'll spit out 45. If you want to do that and you think that's faster, you can do it. It's going to be laborious either way. So whichever way you prefer, it's fine. I'm fine with you using your calculator on those. So what this is doing is, if you've got at least or at most, this one also you could have subtracted, but in this case it made more sense to add, because we only had up to 4. Whereas if we'd started at 18 and subtracted anything above 4, that's a lot more numbers. Okay, so you're gonna decide, are there less numbers to add, or are there less numbers to subtract? And then that way you'll decide whether you're going to add to get your combinations or subtract. Okay, whew, long video, lots of computation. See you soon.